All right, this is Ken Roosevelt. We're going to talk about creating confidence intervals for the population mean when a t-distribution is required. We've talked about when we use a t-distribution, and we know now, I hope, that the only time it's really necessary, sometimes it's optional, but the only time it's really necessary to use a t-distribution is when n is less than 30 and the standard deviation is unknown. Of course, when n is less than 30 and the standard deviation is unknown, you have to know that the population from which you are sampling is normally distributed. So assuming you have that, then by the same logic that I use to explain to you a z confidence interval, or how I develop that formula where you add the arm's reach in either direction to the sample mean, you do the same thing here, okay? Depending on your confidence level, you will select a t-value, and the t-value will be the confidence level subtracted from one whole and then divided by 2. So if you have a 90% confidence level, your alpha is 0.10, and you're going to divide that by 2, and it's going to be 0.05, because you're going to have 5% on either tail. So it's very straightforward, and much like the the confidence level using, or confidence interval using a z distribution. The difference is, because you don't know sigma, you have to use s, and because it's less than 30, you have to use t. So how do you do that? Well, you have a number of options. Of course, I'm going to show you how to do the calculator, the ALEKS calculator, I mean. If you have a TI 84 or 83, you can reference on page 384 a set of directions. Really quickly, just let me explain these. To find a t confidence interval on your TI 83 or TI 84 calculator, you have to decide, are you using data or are you using steps? The difference is, with data, you would have a list of data. You wouldn't actually know what the sample mean is going into the problem. You wouldn't know what the sample standard deviation is going into the problem. And so what you would do is you would type in the data into a list, and then you would proceed from there, and that's this one. So when you're using data, raw data, you follow these top directions here. When you have the statistics, when you have the sample mean, when you have the sample standard deviation, you can use these directions down here. And it is so easy with that calculator. It's beautiful. I love using it. I carry one in class, even though I know how to do it with a table as well. Let me show you the table, the tabular approach. Let's say you want a 95% confidence interval. Well, that's not enough information. For a z-test, that's enough. But when you're talking about a t-test, you have 30 different curves to choose from. So you have to decide which curve. Let's say your sample size was 20, then you would be using the 19th curve, because your degrees of freedom would be 19. So in your book, in the Appendix C, you'll find this table on page 646. Let me zoom in. On it, you have many degrees of freedom, okay? It goes past 30, but after 30, you can see the changes are very, very minute, okay? And you can get away with using a z-distribution. Okay. Alpha is the tail. It's your degree of uncertainty. If you're doing one tail, this is more for hypotheses tests, so you don't really have to worry about this. In a confidence interval, you're always doing two tails, and so it's going to be your uncertainty divided by 2 will be in each tail. Let's look at the 19th curve here. So if you have a sample size of 20, you're using degrees of freedom. You have 19 degrees of freedom. And if you're doing a 95%, or what did I say, 90% confidence interval? I don't remember what I said. But whatever confidence interval you're doing, because this is a two-tail, you're going to use this row, and you're going to look up your confidence interval, or you can do it up top. It's the same thing. If you have a 90% confidence interval, you look across this row to see 90%, or if you're thinking of alpha, it's 10% divided by 2, okay, which would be 5% in one tail. But you can just look across. If it's 90%, you go down that row to the 19th, or down that column to the 19th value in that second column, and the answer is 1.729, and that is what you type in to the formula where it says T alpha over 2. All right, so let's go back. So it's very straightforward. And because it's so straightforward, we're going to go right to Alex now and do a couple of these suckers. So let me log in to my student account, and it's going to take a couple moments, not too long to load. Okay, what I need to review. I'm not going to review right now. I'm going to go to MyPy. And it would be found in confidence intervals in the purple slice. Here we go. Use of the t-distribution. So this is what I mean about data. If you had a calculator right now, you could put this list into L1, and then you could very quickly compute this. But you don't have that, so let's see what we can do. Right here we have sample mean. Right here we have sample standard deviation. So selecting the list, you can just go like that. There's your sample mean. Okay, and I'm going to store that. And now my sample standard deviation, same thing, is that value there. The formula for a t confidence interval begins with the sample mean, x bar, and then has a plus or minus and your t value and all that. So actually, I should probably write down this value. What I'll do is, I can't copy it. I shall have to store that one instead. Store there. Okay, now it's in there. So I'm going to go like this. Let's get the sample mean. It's right there. Arrow over, plus or minus, my t alpha over 2. Now, we want a 90% confidence interval. So my alpha divided by 2. My alpha is 0.10 divided by 2 is 0.05. So I type that in. My degrees of freedom is 1 less than the sample size. My sample size is 20, so my DF is 19. Hey, look at that. I didn't mean to do that, but that is exactly what we just did a second ago, right? In using the table. Now, we saw when I messed up in the other video by not arrowing over. So make sure you get off that bottom line, the subscript, by pressing arrow to the right, hit multiply, and now it is not sigma divided by the square root of n, it's s divided by the square root of n. So s was, recall, that divided by the square root of 20. And this will be my answer. Now I also made another mistake in the Z video, because it said intermediate computations to 3, but round your answer to 2 or 1 in the other video. But this one is going to say 2, so I'm going to say it's 4.757, so I'm going to call that 4.76. And the other one is 4.807, so I'm going to call that 4.81. And that's it. It's very straightforward. Now, what I just said is, based on this sample of 20 softballs, I have developed a confidence interval that the actual mean, I'm 90% sure, is somewhere between 4.76 and 4.81. So I have it down to, I don't even know what those are in. Are those in centimeters? In inches. So I have it down to a 20th of an inch. I have it narrowed down. The average size of a softball, I have it down to a 20th of an inch of precision. So anyways, let's go on. Let's do another one.